Welcome to the Arm Viewpoints podcast, where we bring you technology insights at the intersection of AI and human imagination. I'm your host, Brian Fuller, and today we're diving into the fascinating world of small language models and CPU-based AI inference. Our guest is Julien Simon, Chief Evangelist at Arcee AI, who brings extensive experience from his time at Hugging Face and Amazon Web Services to the leading edge of AI development at the edge. In this episode, we explore the evolution of Arcee AI from its origins in 2023 to becoming a leader in small language model technology, the critical distinction between training and inference in AI, and why inference on CPUs represents an enormous opportunity for enterprise applications, how Arcee AI achieves impressive performance running large models on CPUs through innovative techniques like quantization, and their achievement of running a 32 billion parameter model on an ARM-based CPU, the practical implications of model performance metrics, including the significance of 16 tokens per second and what that means for real-world applications, a look into the future of small language model technology and how enterprises can leverage these advances for better ROI, his fascination with the heavy metal band Iron Maiden, and much, much more. So now, we bring you Julien Simon. Julien, welcome from Paris, where the weather is, I understand, not the best.
Hey, no, it's not. It's not the best today.
Before we dive into the evolution of language models and small language models and inference on CPUs, tell us a little bit about you, your journey. Give us a quick tour of your background.
Sure. So right now I work for a startup called Arcee AI, and I'm sure we'll come back to that in a second. I'm the chief evangelist for Arcee, meaning I spend a fair amount of time traveling, speaking at conferences, chatting with partners, and generally trying to explain to everybody what Arcee is all about and what we build, and do some demos, and of course online content, YouTube and whatnot. Pretty busy with that. And before that, I worked at another startup called Hugging Face for almost 3 years. And I'm sure a lot of you will be familiar with Hugging Face. And before that, I spent 6 years at Amazon Web Services, again, as a tech evangelist working on AI ML services.
Yeah. So toughest question of this segment, Arcee, ARCEE.ai. What does Arcee stand for?
So Arcee is actually the name of one of those transformer robots, the Autobots.
Sure. Okay.
It's a female Autobot. And the reason why they picked this particular one is because two of our co-founders have daughters. And so I guess when they went home and say, well, we're thinking of naming the company after a robot, I don't think they had much of a choice.
So let's talk a little bit about the company now. Let me do my math here. We are 5 years from All You Need Is Attention.
Mm-hmm.
Right? The famous paper that came out of Google in 2017. And your company was founded in 2023.
Yep.
What motivated the founding of the company and the company's focus on small language models rather than following the other fork, which is the development of large language models, foundational?
So we have three co-founders. Mark, our CEO, Brian is our CRO, and Jacob is our CTO. I worked with Brian and Mark at Hugging Face. So it was pretty obvious to us already back then that enterprise users would get more business value out of their models if those were small, open source, customizable models. So Hugging Face, it stands for open source, and that's great. But I think at the end of the day, Hugging Face's customer is the open source community. And I think, Mark and Brian and eventually myself figured out that, we thought we'd do more good working for actual customers. So they started Arcee together with Jacob, who came from RoboFlow. And with that simple, I would say first principle that AI is just delivering more business value if it is based on small open source models that you can customize and that don't require an insane amount of infrastructure to to predict with, et cetera, et cetera. And so they started by building a training platform where enterprise customers could easily bring their own data, their domain-specific data, and tailor open source models to the particular use case they were after. So let's say you want to build, I don't know, a customer support chatbot for telco customers. Well, bring your data, start from a good open source model like maybe Llama or Mistral, etc., and tailor it in a very cost efficient way, because Arcee's stack is pretty clever. Maybe we'll talk about that later. So they started with that, and then they realized, well, if we want to prove that our stack is really good, then we should be building models. And so they started building new models. And what I mean by that is taking existing models like Llama 3 or Qwen 2, etc., and applying the Arcee stack to those models, open source libraries and training recipes, etc., and high quality data sets that we have curated over time, and make them better. Okay, and they started releasing those models on Hugging Face. And for example, they released an 8 billion parameter model, which goes Supernova Lite, which outperformed Meta's Llama 8 billion parameter. They released a 14 billion parameter model that outperforms everything else. They released a 70 billion parameter model. So really the game was, hey, we can build really good models. We have the know-how. We have the tech stack to do it.
Let's talk a little bit about training versus inference, because training for a couple of years was the golden child in terms of the coverage of the rise of AI and generative AI. But inference has an enormous upside, particularly inference run on CPUs. Talk a little bit about that.
Well, I guess training did wonders for the valuation of some companies, but I'm on the customer side, right?
Right.
I'm trying to solve problems for real life people, and real life people are not interested in training models and spending millions on expensive accelerators. They want to solve problems. Can AI solve this problem in an accurate and cost effective way? Yes or no? That's the only thing they care about. That's my world. A lot of companies were led to training or fine-tuning models when they really didn't have to. It's not that easy. It's not that cost-effective. It's not for everybody, right? And obviously, it's not something you should be doing lightly. So training is more. I don't want to say training is for 10 companies in the world, but in a sense, I think it has become that way, because especially when you talk about building new models, the investment required to train a new model from scratch has gone from $10 million to $100 million to maybe $1 billion now, right? If you want to compete with OpenAI or Anthropic or Meta, great, go find VC money, and you'll certainly need a ton of it. Or you can try and do it differently. And I think that's what we're doing. So we're not trying to invent a net new model. We're trying to be clever. So we're starting from existing models. We're making them better because, again, we have what I think is a pretty unique training stack. We do things very differently, and we deliver those outperforming model at very low cost. I think people would be shocked how little we spend when we improve on, Llama 3 or Qwen 2.5, etc. It's nowhere near the numbers that people would expect, because, again, you have to be clever. That's what we bring to the table. We bring better models to our customers. But obviously, most of them, they just want to use the models. And definitely before they even consider fine-tuning and improving on those models for their particular use case, they want to try them out the way they are, right? Out of the box. Does this model solve my problem? Yes or no? With a bit of prompt engineering or with a bit of retrieval augmented generation, can I get what I need from that? And I think a fair amount of customers can, especially since those models are small. So the investment required to deploy those models is very reasonable, right?
Right.
Because that's my punchline. I think no one really understands paper token. And, we've met so many customers who told us, yeah, we started experimenting with the OpenAI models, and before we knew it, we were spending $50,000 a month. And when it's not a question of are we getting ROI or not. I mean, we're probably not getting ROI, but it's just that we can't keep scaling our costs like that, right?
No.
So we like the experience. We know AI and Gen AI is doing some good to our organization and our customers, but the costs are just not sustainable. So we don't want to pull the plug on AI. We definitely want to pull the plug on those crazy bills that we're getting. So can we use smaller models to get the job done? And that's a really good way to start the conversation, because that's the business we're in, which is create small models that deliver the same or hopefully higher business value than those crazy monster models.
You guys play at sort of both ends of the model spectrum with some of your RC models. For instance, you're running RC Supernova, which is Llama 3.1, 70 billion parameters, 70 billion.
Yeah, so I think the largest we have is
parameters.
72B. Yeah, 72.
Okay.
We have a 72B, but yeah, we still consider that a small language model.
Okay.
Because if you, we don't really know, but if we assume that, the Anthropics and the OpenAIs of the world are running, trillion parameter models, or, 500 billion or whatever the crazy number is, 70 billion is still small, and you can still run CB on a single box, on a single server. And that's kind of my definition of an SLM.
So you're doing Supernova you've benchmarked it on Arm Neoverse V1, V2. It outperforms GPT-4o and Claude 3.5 Sonnet. Talk a little bit about how you've been able to achieve that outperformance.
Yeah. So you have those two dimensions, let's call them. So the first dimension is how close can we get to the state-of-the-art performance of, let's say, GPT-4 or Anthropic, etc., with a model that is, let's say, 10th of the size, right? Hopefully smaller, but the smaller the better. But can we that's the first promise we want to keep to customers. We can give you, on your enterprise use cases, we can give you comparable performance, hopefully better performance, with a model that's just a fraction of the size. That's where the training stack is important. It's not just, sometimes people tell me, oh, you're a fine-tuning company. I'm like, no, we're not. Of course, we do fine-tuning. There is fine-tuning in the pipeline, but it's much more than that. So in the last year, our research team has actually built and published a collection of open source libraries. Some of them may be familiar to our listeners. So Merge Kit for model merging, Distill Kit for model distillation, Spectrum for parameter efficient training. But these are the main ones. So again, we're trying to, because if we set to spend 50 million or more on building those SLMs, I guess the business case for RC wouldn't be that interesting. And again, procuring the infrastructure and running those training jobs for 6 months, we would never have the same velocity, right? Those techniques like merging and distillation, etc., are much more efficient than, I would say, brute force pre-training. That's how we do it. And it's a combination. If you look at go to our blog, if you want to know more, you'll see articles on how we build Supernova and other models. And you'll see it's always a combination of distilling from a much larger model and merging different variants of the same model trained on our high quality data sets, et cetera, et cetera. And all those steps are pretty compute efficient compared to brute force training on GPU clusters. So that's the first dimension, right?
Okay.
And that's how we get the quality without spending, insane amounts of money. Okay, so that's the first dimension. Second dimension is how effectively can our customers run those models, whether it's in our SaaS platform or whether it's in their own infrastructure. How can we shrink the cost of inference, and how can we help them deliver maximum ROI, right? Because ROI for AI applications is a very interesting concept. The cost part of the equation is super clear. You need GPU XYZ to deploy the model. It's going to cost you this many dollars an hour or a month. Whether the model is running or not, that's what it is. But how much money the model is going to make you or save you is generally a little fuzzier, right? To me, the best way to get ROI is to minimize the cost while you figure out the revenue. You can act on one piece of the equation. So if you can shrink the cost, even if the revenue or the savings are a bit unclear, there's a better chance that you hit some kind of good number because you were clever in optimizing the cost element. And that's where, again, those models being small, if you insist on running them on GPU, then you can use smaller GPUs, you can scale out architectures, et cetera, instead of having those huge multi-GPU boxes that everybody's obsessed about. And then, of course, you can continue being clever and try to run those things on other platforms than GPUs, right? And of course, I mean CPUs, and that's what we've been doing with some success.
Yeah, and yet you're running a 32 billion parameter model on a CPU, which has sort of a mind-boggling feel to it. How is that possible?
So first of all, and a lot of people go, oh yeah, I never thought about it when I say this, but the main constraint on GPUs is actually not compute, it's RAM. How much GPU RAM, that's fancy HBM, high bandwidth memory, right? That is making some companies so rich. You have a limited amount. And if you don't have enough to hold a model, then you need to start splitting the model across different GPUs. And I guess that's making other companies richer because you need more GPUs again, right? So it's not a good flywheel. Again, if you have small models and if you run them on CPU, then you need to use, you can use, I guess, the host RAM. RAM is not constrained when you do CPU inference. It's not constrained in the same way that GPU RAM is constrained. So that's one. Two, of course, CPUs, even though they have multiple cores and everything, they have nowhere near the level of parallelism that GPUs have. So you need to do something there. Okay, and so when we run models on CPU platforms, we process the models with a technical quantization, which is central to good performance. And basically, quantization is a way to resize model parameters to a smaller size. Models today are, I would say, 16-bit parameters. Okay, so if you say we have an 8 billion parameter model, it means you have 8 billion 16-bit values. So they will surely be stored in your host RAM, no problem there, but you need to move them around and you need to compute them. So in order to reduce the computing requirements and the memory, back and forth requirements, you can shrink those parameters, resize them to, let's say, 8-bit or 4-bit. So that's already, you're relieving some of the, back and forth pressure that needs to happen when you're running inference. Listeners need to take one thing away from this whole discussion. It's cost performance. If you're spending $1,000 on inference, right, how much throughput are you really getting? Cloud is all about scale out, scale in, scale out, elasticity. And so that's what you need to look for. You realize that, you can get a whole lot more done with your CPU dollars than your GPU dollars.
Speaking of cost performance, you often use the phrase 16 tokens per second. What does that mean in practical terms for customers? Because it sounds like it's a cost effectiveness metric.
When we're talking about conversational apps, of course, we need to worry about accuracy and the quality of the text that is generated. If it's crazy slow, if you get 1 word per second, it's like, man, this looks like a movie from the 70s with a mainframe computer or something, right? So that's not the experience you're after. So generally, I think we will agree that tokens are not strictly equivalent to words. 10 words in English, 10 words will be equivalent to maybe 12 or 13 tokens, but tokens include punctuation and so on. But generally, if you get 10 tokens per second, that's considered faster than you can probably read, right?
You've given us a little tutorial on quantization. When you quantize something, there's a bit of degradation in the model quality.
Of course.
Talk about that trade-off.
Sure. The intuition is, okay, if you have 16-bit, imagine you have 16-bit parameters. So it means for each neuron weight, each connection between two neurons between across layers, if the weight is 16-bit value, then it means you have 65,536 unique values. So you have very fine-grained values to describe what's going on between those two neurons, right? Now, if you move to 4 bits, well, then all of a sudden you get much fewer values, right? And you could say, well, the granularity is much lower. So surely I'm losing a ton of fine-grained knowledge and all the finer nuances in that learning process are gone, right? And the answer is, not really. Funny enough, there is a way to measure this. And for smaller models, maybe 8 billion parameters and below, we're talking just about a few percent. So the metric here is called perplexity. And perplexity is how well a model is able to predict the next word. And perplexity, again, for smaller models, usually degrades maybe, 3-4%, which is considered negligible for the huge majority of use cases. As you go with bigger models, the degradation tends to be higher, but there's kind of a compounding effect. But for smaller models, which we promote, it's absolutely fine. And definitely the trade-off is if I get a model that is 97 or 96% as good as the original model, but now I'm able to run it on let's say a cloud instance that costs me 60 or 70 cents an hour, not $6 or $7. Is that a trade-off I'm happy with? Some folks will say no. They'll say no, I need every single bit of accuracy, But if you're building a chatbot, or if you're building I would say non-life critical, non-mission critical application, where ROI is everything, this is certainly something you want to look at.
You've talked about a range of model sizes, 8 billion all the way up to 72 billion. Can you talk about performance patterns that you see emerging across different model sizes?
We're able to match the best models out there with 70B or 72B models. You mentioned Supernova, or our new platform, which we launched yesterday, as a couple of large models which are in the 70B range. And our customers tell us they get, like I said, equal or better results from those than from the large models they're using today. Again, at much lower cost. I would say for narrower use cases, let's say you want to build, you want to focus a model on a particular industry, and maybe even, your a particular use case in your company, you can absolutely get the job done with, maybe a 7 or 8 billion parameter model. So that's really where it is today. And that's why we don't do anything bigger than 70B, because we see the performance that we want from those 70B, and we can run them cost effectively.
What are customers seeing when it comes to results, and does instance type matter in that case?
The first thing folks look at is, how does the model answer their prompts? Is the model doing a good job? Yes or no? Because if it doesn't, you could say, well, but we can run it for super cheap. Yeah, but it's bad. So it has to be good. Okay. And then you can talk about, you can look at how much scale they need from that thing. How many users, how many requests per day, the typical length of a question. Do some capacity planning in a sense, right? Because if you have 10 users using that thing 10 times a day, it is very different from 1,000 users using it 50 times a day. And again, ROI will be different from one use case to the next.
Yeah.
If you're the largest mobile operator in the US, and you have hundreds of thousands, maybe millions of calls to your call centers every day, you will have a very different definition of ROI too. Again, one size doesn't fit all. So one model for one customer would need to run on GPU because they have enough traffic and enough ROI to justify that. Others might be much more cost sensitive, and they may be looking for the most inexpensive way to deploy those models. I think that what's great about SLMs is that you do get that choice. You don't get that choice with the large models. You pay per token, and those things run on those monster GPUs.
So, Julien, what's driving the adoption of small language model inference and AI agents in the market, and why are ARM-based processors particularly well suited for these?
Well, I think enterprise customers realize that large language models, although they have interesting abilities, also have shortcomings in terms of domain adaptation, in terms of privacy sometimes for regulated companies, and of course in terms of cost. Right? Yes, they have abilities, but those come at a cost. And let's face it, for most of your queries, those abilities are not necessary. If you're looking at your daily, use of language models for, your day-to-day prompts, translating this or summarizing that, or rewrite this email, or write an email to organize this meeting, whatever. Those are low complexity queries that do not need large language models. But at the same times, you may need a deep domain knowledge, and those large language models fall short in a lot of cases. So the need for cost efficiency and tailored models, I think, is what is driving a lot of enterprise customers to use, considering small language models. We released a model a few weeks ago that's a 10 billion parameter model that is better than the 72B model we released in last July.
Was
And
that
that
Vert
72B model, that's Virtuoso Lite.
Virtual Light? Yeah. Okay.
And that 72B model from last summer was the best 72B model you could get on Hugging Face. So it wasn't a bad model at all. It was the best in its size. So, I'm not claiming yet that 10B is the new 72B, but this goes to show models are getting smaller and they're getting better too. So they're getting so small that now it is really possible to run them on CPU platforms, because you leverage instruction sets, and the ARM CPUs have introduced dedicated instruction sets to accelerate deep learning operations, matrix multiplication, etc., etc.
I think with respect to that Virtuoso Light model, you wrote that there's a 4.5x cost performance advantage over x86 with ARM CPUs. And you talked about specific scenarios that CPUs might be cost effective alternatives to GPUs. What does that mean for customers?
When you're looking at workloads, you're mostly looking at how much throughput am I going to get. Okay, and I think that's the key metric. A lot of people are obsessing over latency. How fast am I getting the first token, etc., etc. And yes, it matters, especially if you need very snappy, very fast conversational apps, or I don't want to say real time, because I don't think real time and language models should be used in the same sentence. But really, it's how many tokens am I getting out of that model, right? And when I talk to customers, a lot of them have small scale needs. The world wants you to believe, you need to be able to spit out 1,000 tokens per second, 24/7, etc. But a lot of business scenarios are quite the opposite. They have small scale. They have sometimes non-latency sensitive use cases like document processing, stuff that runs overnight, etc. It's not even conversational. And if you look at it that way, then speed is a bit irrelevant, and it's really a case of, okay, how about cost performance? How about right sizing my inference infrastructure so that, yes, I get the job done in the time frame I need to get it done, which could be, I don't know, maybe 30 seconds for a conversation, or maybe I just need to process documents overnight and that's it. And am I still saving money or making money in the process, right? Am I getting ROI out of that? And again, a lot of enterprise scenarios are very narrow, and small scale. So it's not, hey, I have this one model that serves all my needs, and I need to get 1,000 tokens per second out of it. It's more like, well, maybe I've got those 20 chatbots or 50 chatbots deployed across the company, and those, are not even maybe idle most of the time, or they get a few hits per second at most. And so it's not really reasonable to deploy GPU instance for each one of those, right? Because they're going to be idle most of the time. And as we said before, because those models are small, even small GPU instances may be oversized, right? So that's really when you realize that, you realize, I need to right size my infrastructure. And in technical terms, what this really means is a lot of those use cases are batch size one. So you send one query to the model, get the answer, and then maybe 30 seconds later, somebody else will ask an answer. So for those small scale scenarios, GPUs are overkill. They're too expensive and they're unnecessary. So those scenarios are where CPU inference is very relevant. What I call the batch size one scenarios. And because the thousands of cores that you have on GPUs are not going to be necessary. There's no parallelism here. You're just serving one query to one user. And so the 16 or the 32 cores that you have on your Arm CPU are more than capable of doing that, right? So that's the scope. And some folks say, oh, of course we're never going to replace GPUs. And I'm telling them that's not what I'm trying to do, right? I'm trying to explain that for small scale inference or inference at the edge, where GPUs are impractical for a million reasons, there is an option to do this on ARM CPUs in a very cost efficient way and still reasonably fast. And if you do need 2,000 tokens per second, my friend, of course, go use GPU instances, right? So in that context, ARM CPUs are the best platform, right? I work a lot, with Llama CPP. That's my go-to tool. I love the project, and it's very easy to optimize inference for SLMs with Llama CPP. And we work with everybody, but yes, I tried Intel, and that didn't work really well. So I'm just hoping Intel will improve their Llama CPP support and be more of a competition than they are right now. And again, when it comes to GPUs, even the smallest GPU instance, for example, on AWS, is still too expensive at batch size one. I don't think GPUs are the best option 100% of the time, and I know for a fact they are not. Okay, so can we please have a balanced, pragmatic, engineering view of the problem and stay away from marketing propaganda?
Yes, that's my answer. Yes, we can.
Thank you. That makes two of us.
So let's talk about the software ecosystem a little bit,
Yeah.
and your use of ARM Clyde and the quantization process.
Sure.
How important is that as a puzzle piece to the larger outcome?
It is a crucial piece. It is a crucial piece. Of course, you can take the vanilla model, in probably 16-bit precision, and you can run it, say, with Llama CPP, my favorite tool, on ARM CPUs, on Graviton on AWS or other instances on other clouds, and it does work. It does work. It's not gonna crash. It's not gonna go wrong. It's just a little bit slow because it is a bulky model. I mean, if we're looking at our latest model, which is called Blitz, it's a 24 billion parameter model. Well, that's 48 gigs worth of parameters plus everything else. So that's quite a bit of data. You need to move back and forth between the RAM and the CPU, etc., etc. Right? So quantization will shrink the range of parameters from, let's say, 16-bit to 8 bits, or even 4 bits. Why not? So obviously that makes the model smaller. That removes some pressure on the memory bandwidth, but most importantly, it makes it possible to leverage the again the integer instruction sets that are present in ARM CPUs, and so all those typical operations like multiplying matrices and vectors, or multiplying matrices with matrices, etc. Dot products and all that good stuff, which is really the bread and butter of deep learning inference, becomes accelerated, right? And to leverage those instruction sets, of course, you do need software support, and that's what those Arcee AI kernels are. So just to make it clear, it's not really an end user tool that you would grab. It's really, if you're a framework builder, if you work in the PyTorch team, or if you work in the Llama CPP team, or if you are, maybe trying to build your own inference stack, why not? Then yes, those kernels matter, and you should absolutely use them, because they're written by Arm, and those teams know their chips well. So yeah, they are important.
So I think I need to start addressing you as Monsieur Ambassadeur, because you're
Well,
now an
I don't
ARM
know.
ambassador. Talk to us about that. What's that all about?
Again, it's great recognition, for our collective work at Arcee, realizing that yes, well, AI is a thing, but AI on CPU is a thing, and SLMs are showing the way, and I think it's nice to get a chance to address a wider audience, and get a little bit of recognition, and again a little bit of support. So yeah, I'm looking forward to do more with our developer relations. It's gonna be fun.
What excites you in the context of the ARM RC technology roadmap?
We need to go smaller. And there's no reason we won't. Honestly, there's no reason we won't. Uh, you know, if 10B is the new 70B, then why there's no technical reason to stop there. Why can't 4B be the new 70B? So I think that's what excites me. Keep driving hardware innovation. I'm waiting for the next Neoverse generation, and I'm curious to see how this will be leveraged in frameworks. PyTorch is doing a lot of good work, and again, Llama CPP is doing a lot of good work. I'm sure there will be others, and maybe see if model architectures can adapt to that. That's I don't have the answer, but is there a way to build SLMs that would make them great edge models? I'm sure the answer is yes.
Now I'm going to hold your feet to the fire and have you look to the
Let's do it.
future.
Yes.
So, what developments in small language model technology should enterprises, your customers, be looking out for?
I'm sure a lot of folks listening to this are software engineers, and
Right.
hopefully that my analogy will resonate. Remember 20 years ago, and just for the record, Brian and I, we have gray hair, right? So we'll remember 20 years ago. I mean, a lot of us were building huge applications, enterprise apps, probably in some sort of Java framework. That was the way.
Yep.
That building
was the
those
way.
huge monolithic apps, which did probably some good overall. But then, a few years later, those monoliths became hard to scale, hard to maintain, hard to debug, hard to evolve. And so we started breaking the monoliths and we built APIs and microservices, etc. So guess what? I think we're doing exactly the same with AI models, except of course things move faster. So we don't have to wait for 15 years for AI microservices to be invented. It only took a few years to start breaking OpenAI GPTs into a constellation of smaller models that collaborate together with agents. So that's exactly what we're building today, because we know the monolith never really works. And I think now folks understand that, and all that talk about agents is exactly that. Combining high quality small language models that know how to do one thing very well. So I've got let's say my general purpose model, and I've got my coding model, and I've got my vision model, and I have maybe my speech to text model, et cetera, right? And we build those. That's pretty much what we announced in our new platform, which is called Arcee Orchestra. And of course, you need to plug those models into traditional applications. Because another key learning is that, you know what? Models are probabilistic. So they're really good at that, but they are statistical beasts. They're, you can call it AI or Gen AI or anything you want. At the end of the day, my friends, it's still good old math and stats. Okay. If you're the CFO of a listed company, I don't think you want probabilistic answers to your questions.
No, you don't.
And what I'm getting at here is in the last 20 years or 30 years, folks have been writing IT applications that know where to find the unambiguous data on the question you have. If you can connect the models to those apps, which themselves have access to the data, now you have the winning combination. And now you have your collection of models and agents, and you can build workflows and orchestrate all that stuff. And this is how you can outperform even the best model, because that model will only give you whatever it's been trained on.
So you're an Iron Maiden super fan. You have a gold record on your wall. You showed it to us in an earlier call.
That, yeah.
Do you see any parallels between Maiden's evolution from raw power to technical complexity and the evolution of language models?
Yeah, I think I do. Iron Maiden and a lot of bands start, they start with a very raw approach, right? Hey, Metallica fans, you know what I mean, right? The first album can't get rawer than that, but still, it does the trick, and delivering that first wave of models. But over time, you need to explore more, and you learn to play your instrument a little better, and you learn a more nuanced and more complex way to write music or to build models.
Do you see any challenges driving the broader adoption of CPU-based AI inference, or is it blue skies and sunny temperatures?
No, I think it's not. I think there's there's clearly a battle to be fought here. Number one is awareness. I think it's a lot of folks will stare at you funny when you say CPU inference, especially for larger models. So we really need to show what it's all about. We need to show the performance. So the generation speed we discussed, we need to show the accuracy and the minimal degradation, and we need to show the ROI. Because once you show that, once you tell people, hey, why are you paying $100 an hour for a large GPU instance in the cloud, where you could be paying a few dollars per hour for a bunch of CPU instances, that would probably be enough, right? And if you need to scale out, then go and scale out. You're not going to have any problem procuring another 60 or 80 CPU instances. You will probably have to sell your kids to get another GPU instance from your cloud rep, right? You need to show them that.
Well, Julien, I can't think of a more informative hour that we've spent learning about AI and the evolution of language models. You've been very generous with your time. So thank you. Best of luck to you and the team at Arcee, and we'll check in with you in the future. Keep up the good work.
Yeah, we're just getting started. Check us out. Thank you very much.